Hey gang, Professor Feeser here. I provide education solutions to large groups and organizations. You need a learning solution for your team or your enterprise, feel free to reach out. My contact info is at the end of the video. It's also over on my website. Today we're going to talk about Ansible and idempotent behavior. Idempotent behavior. I've prepared two examples for us to study this phenomena. First, let's talk about what idempotent means. You can see I'm in a directory here, code with Feeser, idempotent. In terms of, let's say, Ansible, it means Ansible's not going to take behaviors unless it knows those behaviors need to be taken. Typically, we're referring to tasks. Tasks will only be executed if a task actually needs to change its state. This is really important to embrace. Features like handlers are completely dependent on you being able to write an idempotent playbook. Now, a handler is triggered by a task that elicits a changed operation when it runs. So it's really important to design tasks that are intelligent enough to only make changes if they need to make changes. So how in the world would we do that? Well, the answer is just use the module. When you write a playbook, an Ansible playbook, select the module that's the best fit. Now, you don't know what you don't know. That is to say, let's suppose you wanted Ansible to make an API call. I have two playbooks here, playbook idempotent and playbook non-idempotent. Go out on a limb and say playbook non-idempotent is the not correct way to do things. You would not be faulted if you were new to Ansible and thought, oh, okay, I want to make a curl command. The tasks that I'll design, I can use curl. I could use Ansible built-in command module, and I could just pass it the curl command. That right there is the Linux command to send an HTTP GET. And so if that's how you do it in Linux, sure, I'm buffering that through the Ansible subsystem. Fantastic. Well, what we have here is that gets saved, whatever comes back, gets saved to results. I only display that if I throw a V flag here. So if I do an Ansible playbook and then a playbook non-idempotent, the debug task won't run. Debug is displayed to the screen. And I don't really need it to. It's just the HTML of my web page. The bigger deal is that because we use the command module, we got non-idempotent behavior. Look at this. Changed. Well, here's the idempotent test. Run the playbook a second time. If you get any yellow on the second run, you failed the idempotency test. It's a pretty easy test to run. The concept's pretty clear. That needs to say green, okay. The thinking here is the first time Ansible runs, it's putting configuration in place. It's making systems look the way they're supposed to look. Down here, running on the heels of the first one, there shouldn't be, state should be achieved. It shouldn't say changed anymore. So on top of that, let's think about what's happening here. This is a HTTP GET. That's what your browser sends to go to Google, right? There's no change operation there. It's a read-only command. So there's lots of reasons this output that says changed is incorrect. We didn't modify state. This idea of, well, why is it behaving this way? I told you, that's too broad. Ansible built-in command, you can send any command you want in the world. All this does is register the run code that comes back. It's effectively a number 0 through 127 that says this was successful or it was a failure. 0 means success. Every other number means failure. So command just says, yeah, okay, I issued a curl and I got back a 0, so change. A command and a it was successful, it assumes means changed. So let's look at a proper way to do this. There was a second playbook here. It's called playbook idempotent. So we'll look at playbook idempotent here. Idempotent behavior. I'm no longer using command. That's been replaced with Ansible built-in URI. The URL is now passed as a parameter to that. That's a Python script. Command's a Python script too. It's a really dumb Python script. It can issue any command. This is very narrow, highly intelligent. It only knows about its subject, which is sending HTTP requests to URLs. But it does that really well. As in, if I run this one, Ansible playbook idempotent, this will actually be green from the first time. This is so intelligent that it understands that an HTTP GET could never provoke a change. So if the method you choose is GET, it's just green from the first time. So naturally, there's idempotent behavior there. The takeaway from this lesson is choose the module that's the best fit. In this case, the URI module is a better fit than the command module for sending HTTP messages. It's more specific. We could say best fit, the most specific solution for the problem at hand. That said, especially when you're starting out, you're going to do a lot of reaching for the command module, reaching for the shell module to achieve some end result that you want. But run that test I told you about, the idempotency test. Run the playbook once. Run it a second time. You want to see green on the second run. If you do, you've achieved a playbook that exhibits idempotent behavior, and that's a best practice when working with Ansible. Wow, that was super straightforward. We try to work through modules that are the best fit, that are the most specific to the task at hand we're trying to solve. That makes sense. We try to stay away from things like command, like shell, like raw. And that would be across all disciplines as well. There are modules like iOS command. There's modules like EOS command for Cisco and Arista. All the major vendors that have a proprietary operating system have a command module, I think, off the top of my head. We don't want to work through those, right? Those are too generalized. They're not abstracted enough. They're not a good fit. Gang, I hope you learned something in this video. If you did, go ahead and hit like, hit subscribe. I want to see you in the next episode of Code with Feeser.